This is for designers using Fusion 360 who need to do CNC machining. If you don't own a CNC machine, you can use ours. Welcome to SendItCNC. Today, we're making the lid for the elevated and more beautiful version of the aluminum CNCer's box that we were working on in the previous video. That was drilled and tapped so we could screw a lid on it. Today, we're going to finish that project up by machining the lid for the box. An interesting thing that we'll do here that we haven't done before in these videos is engraving. Welcome. As you know, we're doing something radical and new here, running your CAM programs on our industrial CNC machines in the cloud. As always, we're going to assume here that everybody is comfortable with the concepts and terminology used in CAM and CNC machining. There is great CAM learning material for the Fusion 360 community, and there's a list of a few on the SendItCNC website. In our last video, we completed the bottom part of the elevated CNCer's box, and today we're going to make the lid, which can be screwed onto the box. You can see the box top, and we have some counterboard and chamfered holes for the socket heads cap screws that will hold the top of the box on. Let's just take the box out of visibility for a moment, and the Allen head screws as well. Today we'll make the lid, and that will provide a couple of interesting examples of engraving. Let's get started. We'll go super fast on parts of our work where you've already seen the techniques in our previous videos. First, we'll create a CAM setup so we can machine our part. On the Utilities toolbar, click on the SendItCNC add-in and the Manage Setup command window will appear. All that's required is to select the model, the lid in this case, and click Create Setup. Once the setup is created, in the Fixture/Op field, pick Fixture for Second Operation. Now we're looking at the setup for the second operation. Click the Operation is Used checkbox and click OK. And here's a sketch that contains the engraving. As you can see, the sketch includes the SendItCNC logo, but of course you can edit it to put in anything you'd like. We'll save this as BoxPlus lid, first and second ops. And now we're ready to go over to the manufacturer workspace. We'll use the provided CAM operations as we've done previously, so click Generate to compile them. We'll just delete the adaptive clearing operation, but we will keep the facing operation. And we'll turn off visibility sync and then take the work holding device out of visibility in order to give us a better view of the workpiece. Next, 2D contour to finish the perimeter, and 3D contour to round the top edge. But to save time, I'm just going to take a shortcut and copy operations from the previous video and paste them into this project. When I do that, I'll have to reselect any contours. Now we're going to drill and counterbore the holes for the screws. The easy way is probably to start with the spot drill tap template for thread size 832. We have no intention of doing the tapping operation, so we're going to delete that, and the same with the chamfer operations. The reason for picking the 832 template is that the drill for the 832 tap is a number 25 drill, which is 0.1495 inches in diameter, which would probably be okay for this application. The size of the hole that is called for is 0.15 inches, which is so close. But we'll change the drill to the next size up, which is a number 24 drill with a diameter of 0.152 inches, recognizing that it'll be a couple of thousandths of an inch oversize. When we do something like that, we always need to get the buy-in of the design engineer. For the spotting operation, just choose one of the counterbore faces and click Select Same Diameter. And for the drilling operation, once again, Fusion is pretty smart when it comes to holes, and it is merging the different hole diameter segments together so that the area that is counterbored is treated as part of the hole that we're drilling at 0.152 inches in diameter. We'll go over to the tool library and to the drills and select the number 24 drill, replacing the number 25 drill. Then select the hole we're trying to drill. We have to be careful because if you select the counter bore, it will only drill to the depth of the counter bore. We actually want the drill tip to go all the way through the hole and break through a small amount, say another 50 thou beyond. Note that it'll still be a blind hole because we're drilling into the extra material that is still present on the bottom of our workpiece. Now we want to do the counter bore, and here's an expedient approach to that. We'll use a 3D adaptive clearing operation, but we'll do it with an optional tool this time. We'll use tool number 51, which is a 1/8 inch radius end mill with a radius of 0.008 inches, 0.008 of an inch. We select the counter bores to show the 3D adaptive tool path where to machine. We can set stock to leave to 0 and tighten the tolerance, and the adaptive operation will probably leave an acceptable finish for the counter bore. Turn on flat area detection in order to get it to machine right at the bottom of the hole. Note that the radius on tool 51 will leave a 0.008 radius on the bottom of the counter bore, which is very close but not exactly as modeled. If we wanted to perfect it, we could add a 2D contour operation with tool number 50, which is a flat end mill. Okay, we're ready to chamfer the top of the 4 counter bores, and then they're complete. Now we've arrived at the point where we're ready to do the engraving. Let's show the sketch. First, we'll do what's referred to as V-carve engraving for the logo. We just go to Create from Template, pick the template from the 2D folder called Engraving. The engraving tool is selected, and we just need a contour selection. We'll pick that up from the sketch. As for depth, a couple of hundredths of an inch is about right for engraving that's this height, and it should look nice. Now, if you were to take a close look at the toolpath, you would see that the toolpath is carving the letters so that the text is rendered in the specified font. Okay, along the arc, you can see the stick font engraving that we want to do. This kind of font is referred to as a single stroke font, or sometimes a Hershey font. It's very appropriate for CNC and creates a simple engraving toolpath. One of the most common single-stroke fonts is called the simplex font, which is used here. We'll create from template again, and this time pick the 2D template called Stick Font Engraving. This is actually a 2D trace toolpath with the engraving cutter. In lettering of this height, 5 thou deep is appropriate for stick font engraving, and that should look very clean and elegant. Here's what those engraving operations look like in Fusion 360's CAM simulator. Now we need to flip this part over and do the second setup. So generate the operations, and in the adaptive clearing operation, we only need to rough down to the horizontal surface, not all the way to the model bottom, which would actually cause a collision with the vise. Now we're going to machine those curved surfaces with a 3D contour operation. You've seen this before in the previous video. Still using tool 91, we'll select the machining boundary. It'll be a contact point boundary, and we're going 30 to 90 degrees, and with a step down of 0.005 inches. Then we create a derived scallop operation to machine from 0 to 33 degrees, just a couple of degrees of overlap. Step over 0.005 inches. The scallop operation is doing way too much, so we'll tell it to avoid the 2 horizontal surfaces. We'll add a 3D horizontal toolpath at this point. We'll use tool number 91, and we'll restrict the horizontal toolpath appropriately. And then finally, a 2D chamfer operation. We'll make sure we have chamfer tool number 33 and select the bottoms of the holes. That chamfer toolpath looks suspicious. Let's check it out. It's interrupting our chamfer toolpath in an effort to keep the cutter well clear of the part. We'll just reduce the clearance to 10 thou. And now the toolpath looks perfect. Let's simulate. And it looks beautiful. And let's simulate the first and second job steps together. It looks great, disregarding, of course, the phantom collisions in the combined simulation. We can submit the job to SendItCNC. Notice the extra optional tools we used, in this case the 1/8 inch corner radius end mill and the engraving cutter. We submit the 2-step job to SendItCNC, and we'll have our part in our hands as soon as the very next day, like CNC magic. Complete with engraving. CNC machining for designers, product engineers, and visionaries. SendItCNC, the democratization of manufacturing. Check out our other videos.